Alright, so here in lesson 2 we are now looking at multiplying matrices together, and this one's a little bit trickier because of the way you have to match up the corresponding parts within the matrices. So first things first, there are limitations to this. You can only multiply two matrices under these conditions. And so if my first matrix is this many rows by columns, and my second matrix is this many rows by columns, notice what has to be true here. The columns of the first matrix must be the same number as the rows of the second matrix. And so these two interior numbers have to be the same in order for you to be able to multiply. If these are the same, the result that you get is this many rows by this many columns. And so that's what your answer would look like. And so let's look at that with some real numbers here. So if I wanted to multiply a 2 by 3 matrix with a 4 by 3 matrix, so just like we were seeing up above, these interior numbers must match up in order for you to be able to multiply. And if they don't match up, you have to simply say that you can't do it. It's like a no solution case or not defined or however you want to say that. So here's what should happen. So if my interior numbers match up, so this guy has a 3 and this guy has a 3, so because this columns match these rows, I am allowed to multiply. And if I multiply, my result would be a 3 by 2 matrix would be the result. And so that's what you're seeing within these guys. So when they match up, here's how this works. So as I want to multiply, like this would be a 2 by 2 times a 2 by 2. And so according to the rules from up above, we're allowed to multiply these. Here's how you multiply. We always do rows times columns. And so as you look at the result that you're seeing over here, so if I were to do this row times this column, this is what that would look like. When I do the top row times the left column, it will go in the top left part of my answer. So whenever I use the top row, my answer will go in the top row. When I use the bottom row, my answers for those will go in the bottom row. So again, here's what this would look like. So if I did the top row times the left column, I'm doing A times E plus B times G. And that's where that would go in the top left. If I did the top row times the right column, that's going to go in the top right. And so I would do A times F plus B times H. And all that, when I simplify it, will go in the top right. And so this is kind of a great way of seeing how all this will play out, just as a sort of reminder of the operations and where the answers would go. Let me show you one with some real numbers involved. So if we did A times B, always got to check first, can I do it? And so I have a 2 by 2 with another 2 by 2. And as you look at these, the interior numbers match, which means yes, I'm allowed to do it. So therefore, the exterior numbers tell me what my answer will look like. It will look like a 2 by 2 matrix. So as I go on to the first one, we're doing the top row times the left column, and that will go in the top left. And that's where this number is going to come from. When I do the top row times the left column, I'm going to multiply the 1 times the 3. I'm going to multiply the negative 2 times the 7. And so here's where you're seeing that. I did the 1 times the 3, the negative 2 times the 7, and I'm going to add those results together. And when I do that, I'm getting my top left number. When I do the top row times the right column, it's kind of like distribution. I'm going to take this top row, distribute it to the first column to get my first answer, and then to the second column to get my second answer. And since I'm using the top row, these answers go in the top row of my answer. So if I were to do the top times the right, so I'm doing my 1 times negative 6, that's what you're seeing right here. I'm going to do negative 2 times negative 1, that's what you're seeing right here. And I'm going to add those results together. And when I simplify all that, that's going to go in the top right position of my answer matrix. Once I've done the top row times both columns, now I'm going to do the bottom row times both columns. So if I did my bottom row times the left column, it's going to go in the bottom left part of my answer. So I'm going to basically be distributing the bottom row now to the first column and then to the second column in order to get these two answers. So I'm going to do this row times this column. So I'm doing the 5 times 3 plus negative 4 times 7, and that's what you're seeing right here. So this is how we would set that up. And if I simplify all that, it's going in the bottom left. As I do my bottom row times the right column now, so I'm doing the first numbers together, 5 times negative 6. I'm going to do the second numbers together, negative 4 times negative 1, and then we're going to add those results together. And so this is what that setup looks like. A lot of times I'll see people use highlighters, which I think is kind of a great way to go. It's just sort of a good visual, but here's what that would look like. So just to kind of go back to the beginning, if I did my top row times my left column, right? So I'm doing my first numbers together, 1 times 3, and my second numbers together, negative 2 times 7, right? And that's where we got that top left part of our answer matrix right there. So anyway, you can do that. You can use, colored pencils or pens or highlighters or whatever if that helps you sort of give you a better visual, but that's the way these guys would play out. So let's take a look at another example right here. So now if you look at this one, I have a 3 by 2 times a 2 by 2, and again you can see that the interior numbers match, which means yes, I'm allowed to do this. So the exterior numbers, 3 by 2, is what my answer will look like when I multiply AB together. I laid out all the work for this one as well, so you could see where all these answers are coming from. We're going to start with our top row, and I'm going to distribute it. I'm going to multiply it times the left column, then I'm going to multiply it times the right column, and that's going to give me my 2 top row answers that you see right here. So I'm going to do the 6, 2 times negative 1, 5. Here's what that would look like. So I'm multiplying the first numbers together, the second numbers together, and then I'm going to add the results. And that's where this 4 is coming from. Then I'm going to do my top row times the right column. So I'm going to do the 6 times the 2. I'm going to do this 2 times this negative 2, and then I'm going to add those results together. And since I'm doing the top row times the right column, it goes in the top right part of my answer. From there, you're just going to move to the next row. So I'm going to do the middle row times column 1 and column 2, and that's what you're seeing with these numbers right here. Since I'm using the middle row, those answers are going to go in the middle row of my answer matrix. From there, you would do the bottom row times column 1 and column 2, and that's what you're seeing here. When I multiply my bottom row times column 1, I get this. My bottom row times column 2, I get this. And as I clean all that stuff up, here's what those answers would look like. So let me move on to the second part of this real quick. On this guy, what I wanted you to see is you do have some options in the way you want to do some of these. As you look at this guy here, so A plus B times C. So in this case, you'll notice that we added first and then multiplied that answer times matrix C. So, and that's what you're seeing in this. So when I did A plus B, I got this matrix here. Then I multiplied that one times matrix C to get the final result. On the other side, you're seeing it work the same problem but worked out a little differently. If I distributed that C so that it looks like this, well, now I could do A times C here. I could do B times C, and that's what you're seeing right here. Then I could add, you'll notice I get the same answer that we got over here. I just did it in a different order. So when you're seeing some of these, what I want you to notice is you do have a choice. If I were given this problem to start with, I would have rewritten it by factoring out the C to look like this, because this way I only have to multiply once, right? And in this version of it, we added first, then multiplied times C to get the answer. But in this version, I had to multiply twice. I had to do the A times C, then I had to do the B times C, and then I added to get the same answer. So which version would you rather do? Right? It would be easier to multiply once instead of twice. And so keep that in mind as you're doing some of these. You do have a choice as to which way you want to do it. But one thing that is extremely important when it comes to multiplication is when you do matrices, the order in which you multiply matters. A times C is not the same answer as C times A. And so it's really important that you keep the multiplication items in order. If C is on the right, C must stay on the right as you multiply. You cannot switch the order or you'll get something different. So that's what these rules are basically telling you. And so that's something important to keep in mind as we do these. Let's take a look at one word problem. So we're given some information here for the cost of items. One of these is for middle school. The second row is for high school. And so you can see the way all this was organized here. So I have a row of middle school and a row of high school. And so we're going to keep those as our rows, middle school and high school. The cost that we get for each item, the sweatshirts, the t-shirts, the pennants, all that stuff, we're putting into another matrix that you're seeing over here. Just to make sure that we always set these up correctly, we want to look at the dimensions. Because how should I know? Should I write these vertically as a 3 by 1? Or could I have written them horizontally as a 1 by 3 matrix? And could I have done it that way? According to the rules that we saw at the beginning of this lesson, I need to make sure that my interior numbers match up. And so when I go to set up my matrices, I have to set them up in a way that these numbers match. So if I have a 2 by 3 matrix here, then I have to make sure that if this ends in a 3, that the next matrix I do starts in the 3. And so that's why we set the cost matrix up as a 3 by 1 instead of a 1 by 3. Because I needed these numbers to match. Otherwise I won't be able to multiply them. And so that's why we set these up the way that we did. So here are the items, here are the cost, and since my interior numbers match, I know I can multiply these two together in order to get my answer matrix. Notice again that because my interior numbers match, I am allowed to multiply, and the result will be the 2 by 1 that I see on the outside. And so as I go through and multiply, just like we did in the first page of the lesson, so I'm doing my inventory matrix times my cost matrix, and you can see the way all these numbers are going to work out for us. So here's my inventory times cost. I did the top row times the column in order to get my top row answer. Then I did the bottom row times the one column in order to get my bottom row answer. And so you can see the numbers connected together over here for how we came up with our cost matrix. And so now we're seeing our total cost for middle school and our total cost for high school.